So here is the first set. In a cooperating housing society called La Residencia, there are few families who own a car or cars. Each car owned by these families can be categorized into three types: economy, that cars that cost up to 7 lakhs; dear, cars that cost above 7 lakhs but less than 15; and premium, the cars that are costing above 15. Each family keeps at most one car of a certain category. In other words, the families who own more than one car, the cars are of different categories. More information regarding the family staying at La Residencia and the type of cars they own is given below. So here he is telling you there are three type of cars. A family cannot own more than one car of a particular type, though of course a family can have cars of two types or three types. So maximum three types are there. In other words, we can say the maximum number of cars with the family is three, and the minimum number of cars can be zero when there is no car with them. Then there is more information regarding this. The number of families keeping economy, dear, and premium is this. Number of cars is this, so on and so forth. And we have a few more informations about that along with these 5 questions. Let's start doing the set now. So I put up all this information over here, and I've already made this Venn diagram for our convenience. And the first statement I've already written. So this green circle represents the economy cars, the red circle is for dear cars, and the blue circle is for premium cars. The number of families keeping economy category cars or dear category cars and premium category cars are 27, 34, 25, which are written over here. Let me repeat that these circles are representing the families who are keeping these cars. Now, the second statement. The number of cars in La Residencia is equal to number of families staying there. So we'll be using it at the end because currently we neither have the data about the number of cars nor about the number of families. So let's put it on hold. Third statement. The ratio of number of cars, this is important here. Number of cars, actually, the circles are representing families. Number of cars are different from the families, right? If a family is having two cars, the number of cars would be twice of the number of families. So number of cars owned by the families who own all three categories is E. So the number of cars owned by these E families is 3E. Is that right? There are E families. Each of them is having three cars. So the number of cars owned by them is 3E. To the number of cars owned by the families who own economy category cars, that means among this green circle, and exactly one other category of car, exactly one other. So family is having economy and exactly one more. So that is economy and dear or economy and premium. I would not talk about these because they contain, they have economy and dear and premium as well, whereas it said that exactly one more category. So these B and D are the number of families who are having economy category car and exactly one more car. But the number of cars with them would be double of B and D because they are having two cars each. So the ratio of 3E and twice of B plus D, because B plus D is the families, each one of them is having two cars. So the number of cars with them is twice of B plus D. The ratio says 3 is to 2 is equal to this. So I can straight away cancel out 3 and 2 and I'll get to know from there that E is equal to B plus D. So basically if you write them in the form of fractions, 3 and 2 would cancel out and you would get E is equal to B plus D according to this third statement. Let's come to the fourth one. The ratio of the number of cars, once again the number of cars owned by the families who own a car of dear category and exactly one other car. So once again the same thing. Dear, that is the red circle, exactly one more, that is B and F. So the number of families is B and F, whereas the number of cars with them is twice of that. The ratio of this with the number of cars owned by the families who own a car of dear category and cars of more than one other category. So dear category, that means inside the red circle, and have more than one more category. So more than one more category means at least two more categories. And when I said dear and at least two more is only one area, that is E. A family having dear category car and at least two more cars. That means they are having all the three cars. There is E. So number of cars with these is 3E. This is given to us as 4 is to 3. Once again, when I write them in the form of fractions, it will give me 2 will cancel out it at 2, 3 will cancel out straight away, and I will have B plus F is equal to twice of E. I will have B plus F is equal to twice of E. Okay, next. Next is for the families who own exactly two cars. For the families who own exactly two cars. Now, which are the families owning exactly two cars? Can I say they are B, D, and F? These are the three. So the families having exactly two cars are B, D, F. The ratio of the number of cars of economy category. Now, among these three, number of cars of economy category is B plus D. The point is, these B families have got cars of economy as well as DR category, but the number of cars of economy category would be B. Similarly, number of cars of economy category here would be D. So the number of cars of economy category with one of these three is B plus D to the number of cars of other two categories. Now, what are the cars of other two categories? For dear category, can I say B plus F? And for premium category, it is D plus F. So it is B plus F and D plus F. So basically, it is B plus D plus 2F. And this is given to us in a ratio of 5 is to 90. B plus D is to B plus D plus 2F is equal to 5 plus 19. This whole thing is now there with us. I'm sure that all these equations are clear to you. Once these equations are clear, after that we can move ahead and solve some of the things. How do we solve them? Let's check. So when I say B plus D and B plus D plus 2F are in a ratio of 5 is to 19, so what can they be? Let me check that one by one. One possibility is B plus D is 5. If B plus D is 5, B plus D plus 2F is 19. That's one of the cases. I'm just taking one of the cases. B plus D plus 2F is 19. According to this, now I say B plus D is 5. That means 2F is equal to 14. I'm writing it here. If I have assumed that B plus D is 5 and B plus D plus 2F is equal to 19, it straight away means that 2F is 14, or I can say F is equal to 7, right? I can say F is equal to 7 from here. I hope you are getting my point. Moreover, B plus D is 5. If I put it here, I can also get the value of E then. Value of E would also be equal to 5. So I am getting E as 5, F as 7. If I am getting E as 5, F as 7, by putting them here, I can get the value of B as well. That will be equal to 10 minus 7, which is equal to 3. And if I get B is equal to 3, by putting it here, I can also get D is equal to 2. So by doing that, I can get all the values which is very much within the scope. That's possible. Let's talk about one another case. What if this is equal to 10 and this is equal to 38? Let's take this case as well, because if two numbers are in a ratio of 5 and 19, they can be 10 and 38 as well. Let me write that as well. If B plus D is equal to 10, that means B plus D plus 2F is 38. So 2F is 28, which means F is equal to 14, which means F is equal to 14. If F is equal to 14, B plus D is equal to 10. So from here I can say E is equal to 10. Now the problem is E is equal to 10, F is equal to 14. I will get some values of D and G as well. Of course, I can get them from here. From here, I get B as 2 into 10, 20. 20 minus 14. 20 minus 14 is 6. So I get B is equal to 6. And once I get B is equal to 6 and B plus D is 10, I get D is equal to 4. 4 plus 10 plus 14 makes it 28, whereas this circle was equal to 25 only. I am getting sum of three values itself as 28. So by that logic, I cannot even take them as 10 and 38. And of course, when I cannot even take them as 10 and 38, how can I take it anything more than that? Okay. How can I take anything more than that? I mean, can I take 15 and 57? Of course not. Even this is not possible. So therefore, the only possible solution for us was this. When B plus D plus 2F was 19, B plus D was 5, B is equal to 3, F is equal to 7, E is equal to 5. And I can put all these values over here in this Venn diagram. which tells me that E is equal to 5. I am getting F is equal to 7. B is equal to 3. I'm sorry, B is equal to 3. D is equal to 2. Now 7 plus 5, 12 plus 2, 14. That means G is 11. 5 plus 3, 8 plus 2, 10. That means 27 minus 10, A is 17. 34 minus 8 plus 7, 15. That is C is 19. So this gives me all the values which are required. And then I can even use the second statement. The number of cars in La Residencia is equal to the number of families. So what will be the number of cars? Let's talk about it. 17, 19 and 11 families have one car each, so they have these many cars. Whereas these 3, 2 and 7 families, they have 2 cars each. So there are 12 families having 2 cars each, and there are 5 families having 3 cars each. So the total number of cars is 36 plus 11, 47 plus 24, 71. 71 plus 15 is 86. 86 is the number of cars. He says that should be the number of families as well. But what is the number of families according to the Venn diagram? 17 plus 3, 20 plus 19, 39 plus 2, 41. 41 plus 5, 46 plus 7, 53 plus 11, 64. So where are the remaining 22 families? Those are those families which have no cars. So I can say there are 22 families with 0 cars. So by that, if I calculate the number of cars and number of families, they come out to be exactly equal. And this gives us the right answer to this question. So this is the whole Venn diagram, after which we can immediately answer the questions fast enough. Let's have a look at the questions. Now, I have already put those Venn diagrams later on. How many families in La Residencia do not own any car? As we have already discussed, there are 22 families. So my answer for the first question is 22. Here do we have the second question. How many cars are owned by the families who own at most one category of car? So at most one, that means one or less. So at most one category of car. If I look at that at most one category of car, how many of them are there? At most one is that is 19 plus 17 plus 11. So 19 plus 17 is 36 plus 11, that is 47. 47 plus 22, right? 47 plus 22 is 69. But the question is asking you how many cars. These 22 families have no cars. Now, I have seen many of the students who attempted for this paper, they made a mistake over here. And they gave the answer as 69. Whereas the answer for this question should have been only 47. Why 47? Because when I talk about this case, in this case, what is happening over here? Question is asking you how many cars are owned by them. And the number of cars owned by them is only equal to 47 because these 22 families exactly have no cars with them. So my answer for this question should be 47. Probably you can see on the screen as well, it came 69 before because initially it was typed at 69, but later on it was changed to 47. So right answer for the question is 47. Here is the third question. How many families own exactly 2 cars, one of which is a premium category car? So exactly 2 cars are these and these. And he says that one of them is a premium category car. So I'm not talking about them. So 2 plus 7, there are 9 families who own exactly 2 cars. My answer for this question is 9. And this time he talked about number of families, not the number of cars. So answer should have been 9. Next question is the number of families who own only premium category cars. Let's check that here. Only premium category cars is 11 families. Is how much more than the number of families who own at least 2 cars, one of them being economy category. At least 2 are these and these, but within them, I mean, they should be having economy category as well. So they are 2 plus 5 plus 3, right? So the number of families who own only premium category cars is 11. This is how much more than the number of families who own at least 2 cars, that is 2 plus 5 plus 3. One of them being an economy category car. So 5 plus 3 plus 2 is equal to 10. 11 is one more than that. So my answer for this question should have been 1. And lastly, the question says the number of cars with families who own exactly 2 cars is what percentage of sum of the number of families who own only dear and premium category cars. Let's have a look. Number of cars with families who own exactly 2 cars. Exactly 2 cars is this, and this. They are 12. These 12 have got 24 cars, right? The number of cars, okay, 24. To the sum of the number of families who own only dear category and only premium. Only dear 19, only premium 11. 19 plus 11 is 30. Question is 24 is what percentage of 30? It is very clear that it is equal to 80%. So my answer for this question should be option D, that is 80%. I would rate this question as a moderate category question.